Good afternoon, Justin and Karina. Good to have you here today. We are going to continue working with polar coordinates, and what we're doing is we're going all the way to problem 35. And these exercises here involve some algebra and also your calculator for verification. You have your calculator, right, Justin? Great. And so it says convert the polar equation to rectangular form and identify the graph. Support your answer by graphing the polar equation. So basically we're going to use algebra to convert. And when it says rectangular form, what does rectangular mean? What do rectangular equations have, for example, that this equation doesn't have? Yeah, x and y, right? So we're going to use there are three main formulas we're going to use. Actually, many, because we're going to use all the identities of trigonometry. Essentially, are the main ones. But basically, we have x equals r cosine theta. So you all remember that one, right? That's an important one. And what would other equation be? Y equals r sine theta. Very good. Okay, Justin, excellent work there. And then here's one that probably I know you're not exactly ready for, but I'll tell you what it is. It's this one here: x squared plus y squared equals r squared. You ever seen that before? No, I'll tell you what this is. This is an equation for a circle. This is the basic equation for a circle. And then there are different forms. There's also this form here. If we have x minus h squared plus y minus k squared equals r squared. So that's a variation. And we're going to use that. So we're going to use variations of all these things, essentially. And so now we start out with problem 35, and we look at this r equals 3 secant theta. And this is set up in form that we could actually graph this in a certain respect in our graphing calculator as a polar equation. But we're going to convert this into a rectangular equation. And you have an idea of how to do that? You don't? Okay, if you don't have an idea of what to do on this one, count me in for not blaming you a bit. Because this one here, I don't see anything intuitive at all versus what you've done in your mathematical career for this. And so what we're going to do is divide by, we're going to divide by 3 secant theta. Okay. And then, actually, excuse me, I lied to you. We're going to divide by secant theta. Just secant theta. Okay? And we did that to the right side. What are we going to do to the left side? Same thing, right? And so now we cancel out on the right side. And so we have r over secant theta is equal to 3. Okay, now what about r over secant theta? Do you notice anything you can do with that? Well, what is secant theta? I'm just going to write a little side. Actually, I'll write it up here. What is secant theta? Remember what that is? On your ACP formula chart.
It's the opposite of one of them.
Yes, it's the opposite of, or you should rather say the reciprocal of one of the things. Well, it's 1 over cosine. Yeah, that's what it is. And so what it is this can be rewritten therefore as r cosine theta is equal to 3. Okay, do you follow that? It makes sense? Okay, what can we replace r cosine theta with? X. So we're going to go ahead and take this x over here and replace that r cosine theta with x. And so what are we left with? X equals 3. And so we've made some algebraic maneuvers here, haven't we? And we're able to simplify this to a rectangular equation. So we come over here, and when we graph this at x equals 3, so that's going to be a vertical line here at where x crosses the x-axis. So we're going to put x equals 3 right there. Okay? All right, and the last thing we're going to do is go and graph this in our calculator. So we have r equals 3 secant theta. Now, we don't have any secant button anywhere here, and we are not in polar mode. So I'm going to go to the mode button here and change this to polar. One thing that's helpful to have here also is your calculator in radian mode, which it is. And so we're able to graph this, and we can't graph r equals 3 secant theta, but we can write that instead as 3 over cosine theta. So we're going to come over here on a calculator and put 3 over cosine theta. That's cosine theta, right? And then we graph that and we get that. Okay? I don't know, I think that's pretty cool. So to me, in this course this semester, to me, and call me an ultra nerd if you want to, or something like that, but doing these manipulations and simplifications, to me this is amongst the coolest stuff we do all year, to me. But that's me. But there's a lot of other cool stuff this year too, right? So it's hard to compete when it comes to that. So what I want to do is I want to go through these, and you may not have time to do all these today, but I want to get to at least a sampling of all these. So I want you to go ahead and work out number 36. It's a similar type of problem using your identities.
Are you only solving for x or also y? Because in the last time you only did x.
Well, it depends. You could have y, because if we ended up with r sine theta, then that would be y, right? So it really depends on what you find. And so we're going to find this exercise set. We're going to find x sometimes. Sometimes we're going to find y. Sometimes we're going to find both of them. Okay, and sort of work through on that. So it just sort of helps to be open-minded about these. Yeah, those are good questions. Good questions. What did you do for your first step on this thing here? Divided by cosecant theta. Beautiful. Okay, there we have it. So you're on the right track. To me, that is the first step to working these problems out. Okay, have you finished this problem now? Okay, good. Let's take a look at it. So really it's the same type of thing as before, right? So we're going to divide by cosecant theta. So we have r over cosecant theta is equal to -2. And then what is cosecant theta equal to?
The reciprocal or sine.
Yeah, it's reciprocal of sine theta, right? So if we replace this with 1 over sine theta, we get r sine theta equals -2, right? And then what can we replace r sine theta with? Y, so get y equals -2. So we should get this business right here like this, right? So we should get a horizontal line down here, y equals -2, and we go to our calculator and we put in -2 over sine theta. So I'm going to go right here. I'm going to put in -2 over sine theta. There we go. And just graph. Does that look right? Yeah, it looks right. And what I want to do is forward to, make sure we get to, so this one here is really, yeah, go ahead and do this one too. Have you started working on this yet? Yeah, I should work on this one here. This one, yeah, just spend a little time because this one here has really a level of degree of difficulty to it that you probably won't spot right off the bat. I certainly didn't when I first picked this up. And it's like every year I have to look at it to make sure I'm doing this right. Any ideas on this one? One thing you're going to have to do with this one you're going to have to use this equation here somehow as part of the mix in this situation. Well, here, I'm going to show you. What you're going to do, you want to be able to have r squared to work with, and the easiest way to get that is to take this whole equation and multiply it by r. So you're multiplying by r on both sides. So on the left side now you have r squared, and on the right side you have -3 times r sine theta. Okay. Do you have anything that you can replace here now with x and y? Yes, r sine theta is y. So on the right side, I'm going to make this over on the right side, we can put -3y instead, right? Does that make sense? Okay, good. Now on the left side, what can we replace in terms of x and y? Okay, we have this equation here, right? So we can put x squared plus y squared replacing r squared, right? So now we have that in terms of x and y, and so identify the graph. We don't have enough to identify the graph. We know based on this that we have a circle, but we don't know exactly where the circle is, the size of it, or anything based on that, do we? Right? Now, remember we're trying to get towards this form here, x minus h squared plus y minus k squared equals r squared. We're trying to get it to that form. And so what we're going to do is get this negative 3y over here on the left side. So if we add 3y, we get x squared plus y squared plus 3y is equal to 0. In fact, let me just right over here a little bit. I'll put it equals 0 like this. Okay? Everybody okay with that? Okay, we're going to do something that we've talked about in this class. I forget exactly how much we did it. If we did it this year, it's not a whole lot. It's something called completing the square. Have you ever heard of completing the square? We did that some last year, didn't we? And we did it this year a little too, didn't we? Yeah, we did. Okay, good. Well, God, you guys are remembering something from ancient history. And so what we have is we already have x squared right here. So we're good to go on that. So we get, so what we're going to have is x minus 0 squared. There's no problem there at all. And then we're going to have plus, now we want to write this y squared plus 3y as a perfect square. And to do that, what are we going to have to add to this y squared plus 3y to construct a perfect square? Yeah, so we're going to take this middle coefficient of 3 and do what with it? Divide it by 2. Okay? And then we're going to take this and square it. And we take 3 over 2 squared, what do we get? Well, I'm just going to put it in as 3 over 2 squared. It's going to be 9/4, right? But I'm going to put 3 over 2 squared. So what I'm going to do is, I'm going to write it here. So we're going to get y squared plus 3y plus 9/4, which is, I'm just going to put this in as 3 over 2 squared. And on the right side, I'm going to add, since I added 3 over 2 squared on the left side, I add 3 over 2 squared on the right side. Okay? And I'm just leaving some room up here with what I'm doing. And so now, I'm going to come up here and just write and work below. So we have x minus 0 squared plus, what goes in for y? Well, it's going to be y plus 3/2 squared. And that's going to be equal to, on the right side, 3/2 squared. And so, I'm not sure you can visualize with it. So k is going to have to be negative 3/2. And so what we have here is a circle with center at the point x equals 0, comma, negative 3/2 with radius of what? Where's our radius going to be? It's going to be 3/2. Because this is r squared. So radius 3/2. And what that's going to look like is we have 0, negative 3/2. And so we're coming down here, we got an xy coordinate plane, and we come down here, negative 3/2, and that's the center of our circle, and the radius is 3/2. So we're going to have a little circle just below the x-axis that looks like this. All right? And let's go try to graph that. So we have r equals negative 3 sine theta. We should see that, right? Let's go to our calculator. So negative 3 sine theta. And I'm not sure that the window's set exactly right. We'll just graph. And is that what we see there? Yeah, we can go to zoom square to square it up. But that's what it is, isn't it? Okay? So again, to me, be able to do this, I think that's pretty cool. But a lot of algebraic steps to do this, right? There's some manipulation to be done. So, I mean, if you feel comfortable by the end of class doing these kinds of manipulation and all that, I just have to applaud you and give you credit for it. Okay? Good work. Let's go ahead, and I want you to go ahead and do number 38, which is a similar, I think, credential type of problem. Yeah, I think 38, if I'm not mistaken, might be, the arithmetic might be a little easier. But it's the same type of problem, isn't it? Let me see what's going on ahead of that. Yeah, okay. I want you to do 38. And then I'm going to skip ahead to 41. Maybe I get to all these today, which is all right. Yeah, if you do that, and you'll have negative 4 r cosine theta. 4 r cosine theta, yeah, it'll be negative 4x. Yeah. So, same thing as before. If we take this equation, multiply by r, we're going to get r squared equals negative 4r cosine theta, and we can replace r cosine theta with x, right? So on the left side we have x squared plus y squared equals, on the right side, negative 4x. And then if we add 4x to both sides, we get x squared plus 4x plus y squared is equal to 0. And what can we do to make a perfect square out of the x business? What do we have to add? Yeah, we're going to have to add 4. Let's do the arithmetic on that. So if we take 4, which is our middle coefficient, divided by 2, we get 2. And if we go ahead and square that, we get 2 squared, which equals 4. So we're going to have x squared plus 4x plus 4 plus y squared is equal to, what do we have to add on the right side? 4, right? We have to add what we add here. And so we get quantity x plus 2 squared plus, we'll say y plus 0 squared, or it'd be y minus 0 squared is the way we're going to put it. Squared equals 2 squared, right? And so what is this the equation of? It's a circle with center. Where's the center of this circle? At -2, 0, right? And radius of 2. And so what that should look like, if we're not mistaken on this guy, is we should see, like to the left here, we should see a center of a circle right here, and we should see a radius of 2. So the circle is going to be over here looking something like this, right? So let's go and put that in the calculator. R equals -4 cosine theta. So I'm just going to change this to -4, put this cosine theta. That's it, right? And then let me turn off that plot. And then graph. And that's it, right? Okay, good. What I want to do is skip ahead a few problems to problem 41. And 41 is the same type of problem, but has just some more complexity with sine and cosine at the same time. So, but it's going to be the same process here, and I'm just going to go ahead and work this one out quickly, and then leave time for you to work on 42. So if we put r times everything, we get r squared equals 2r sine theta minus 4r cosine theta. And then replacing everything we can, we put x squared plus y squared equals 2y minus 4x. Okay, is everybody okay on that? And then if we get rid of this on the right, we're going to have over here on the left side, we're going to have x squared plus 4x plus y squared minus 2y is equal to 0. And so now what we have here is 2 squares to complete. We've got a square to complete here for this x squared plus 4x. What do we have to add here? 4, right? So I'm going to put x squared plus 4x plus 4. And then what do we have to add here to complete the square with this y business? 2y. What do we have to do to complete the square here? Negative 2 divided by 2, so we get negative 1 squared. So we have to add 1. And then we added 4 and 1 on the left side, so we have to add 4 and 1 on the right side. So we end up with 5. And so we have x plus 2 squared plus y minus 1 squared equals square root of 5 squared. Square root of 5 squared, right? And so what is this? Well, this is a circle with center at, what's our center? Negative 2, 1, right? Negative 2, 1. And what's our radius? Yes, our radius of square root of 5. And so we can just put this in the calculator to check if that's right, what it is. It should be. So 2 sine theta minus 4 cosine theta. I already have minus 4 cosine theta, so I'm just going to add 2 sine theta, right? And just kind of see what we get. So we graph. So we get over here. Now we should have a center at negative 2, 1, right? Does that look right? What about the radius of square root of 5? Well, it's kind of hard to tell exactly, but you can kind of see, right? Like this is going to be, if you go from the center to the right, you just pass the y-axis a little over 2. And I think the square root of 5 is about 2.2 something, or thereabouts. So that's it. So what I want you to do is go ahead and finish out today working on problem 42, see if you can get that. And with that, I call this, well, as good a class as was possible for us to have had today. So that's good. Your window is square mode. You're in radians, that's cool. Here's what we'll do. In the window, you have theta max at 360. What I want to do is make that 2 pi instead. And that might uncomplicate our lives. So I just changed the window for x theta min, theta max, the graph here. Well, here's what you did. Let me show you what you did here. Use the wrong symbol here. You gotta use this one right here. There.
Oh, that doesn't mean it.
And you grab. It's still not working. Okay, you have the theta step of 7.5. Let's change that. 0.1. Okay, that'll fix it. There we go. It's fixed. She had the T step and the range of the T and all that. So that looks right now, doesn't it?
Yeah.
Yeah. So just something to look out for. Well, I'm going to turn off my camera.